And so these are the makeup days. Notes, we don't actually have lab on colloquium normally. And I've done a makeup day on the colloquium week. So you basically, unless you have to make stuff up, yeah, exactly. Exactly. You get a little chance to get ready, right? Yeah, make your life a little easier. Okay. And then we have 23D. And then we have a wrap and an ACS exam. So what we'll do then is we'll come in here. The first hour, we'll work on getting the lab wrapped up and everything perfect for the next class, okay? And then the next 2 hours, we'll take the ACS exam. You guys took the ACS exam last year, right? For the Gen Chem? You know how it is. 2 hours, relatively toughish, right? That one gets applied to the lecture, okay? If for whatever reason you're not taking the lecture, you don't have to do the ACS exam, okay? All right. Anybody have any questions about the schedule so far? Okay. Let's go ahead and talk about the syllabus. Then we'll go through and look at the modules and course real quick. Okay, so this right here is my office hours. That's me as the syllabus. Notice that there is the micro scale right there. That's the textbook you need. This right here is your splash goggles. I actually spent a bunch of time with the bookstore last year, and the bookstore carries they're $5.80, but with tax, I think they're going to go over $6. Goggles, they're actually quite comfortable. Okay, they're pretty decent quality goggles. If you want to get a really nice, comfortable pair, you can. There are actually bigger, really comfortable ones you can get, but you need splash goggles. Okay, does anybody know the difference between splash goggles and safety glasses? Exactly. Yeah, they form fit all the way around, right? Okay. And so there are several different things that have been used up on this floor. Many of them are not going to work, okay? There's safety glasses. They look like glasses, right? There is then you guys seen those glasses that are green up here and they come down like this, but they leave these parts completely open. Those are not splash goggles, okay? They do not protect you from a splash, okay? Splash means splash, right? And so a splash goggle will fully protect your eyes from literally somebody throwing acid in your face. Okay, if you have splash goggles on, no problem, right? You have those green ones on, they're going to wrap up into your eyes, aren't they? Okay, because liquid wraps around, doesn't it? All right. And so, the other one is the safety glasses with the side protectors right here. And they come up like this. Those are not quite going to do because they're still open down here. Okay. And there's just, the problem is we are going to be boiling things that can also be caustic. And so if you spit it right into your face because you had problems, broke it, whatever, I want your eyes to be protected. I want us to have no possibility of having damage, okay? And so splash goggles are what you need. Does anybody have any concerns, comments? Nope. You're going to need to buy your own. You're going to bring them next week, right? Okay. You need this textbook. To be honest, you guys could share the textbooks. I don't care. That's fine. Because you're going to need to write the procedure out from the textbook anyways. So you're not actually ever going to need like that textbook with you all the time. You could just arrange a time to do it. So if you guys want to share the textbooks, whatever. Though I would say this textbook is really worth having. So like buy an old copy of it sometime and keep it somewhere in your trunk of books. Okay. Okay. You'll need a lab notebook. Previous lab notebooks are totally fine. We'll use that same lab notebook. I haven't had any water all day. We'll use the same lab notebook for both semesters, 311, 312, okay? And so if you have an old lab notebook, what you want to do is you want to gather all the pages together that you're not going to be using this semester, take a stapler, and put one staple through them, okay? And that way you can flip back and forth past them really quickly. And then if you ever want to separate them, you can separate them easily, okay? Okay, anybody have any questions about that? Well, let's say you had a lab notebook you used in general chemistry. I don't want you to have to flip through 50 pages to get to the stuff you need, right? Yeah. And so if you staple all the Gen Chem together, you can just flip one. That making more sense? Okay. All right. Everybody good with the lab notebook? If you're tight on budget, you can't afford the bookstore's lab notebook. I am totally fine with a composition notebook or a journal notebook, as long as you can't tear pages out easily and they have lines on them. Though those you'd have to mark your own page numbers and do a little extra work, okay? So the textbook, the bookstore one is just an easier, nicer one, okay? Okay, these are the learning outcomes. If you ever need to transfer this course, that's what you need, by the way, okay? Course description, learning outcomes, there you go. All right. Evaluation, we're going to have participation and check-in, check-out procedure. That's worth 30% of your score. You need to be actively participating with some degree of competence, okay? Does that mean I don't make mistakes? No, I expect you to make mistakes. You're students. You should make mistakes. That's why you're here, okay? If you did all this stuff perfectly without making a mistake, why are you paying money to be here? It's a waste of time, okay? In case anybody is going, I need a diploma. That's not true. You can go to MIT's graduate school without an undergraduate degree. Okay? You can test into programs. That's actually true for all the best schools in the world. Okay? It's just really hard to do, and almost nobody does it. There's few people that do it. So what does active participation mean? It means I'm actually doing things, and I don't like sit back and say, hey, partner, can you take care of all this for me? If you do stuff like that, I will actually pull you outside the class, and I'll have a pretty stern discussion with you. Okay? I have never had to do it in organic chemistry at all. I have had to do it in some of the lower division classes. And usually people fix their behaviors pretty quickly, either because they knew it just wasn't a good thing to do, or I guess maybe I'm that terrifying. One of the two. Like, now that I think about it, every other professor has been like, students have been an issue and the student didn't fix their thing when I told them. And nobody's ever argued with me. They just totally avoid me if they're going to try to argue. So, all right. Colloquium is with 15% of your score. That's done by the judges during colloquium, and I'll just apply those, okay? If you do the colloquium with me, we can talk about it if you want to do the colloquium with me, okay? I'm not terrible with colloquium, actually. It can be kind of fun. And I have a list of projects that I'd like to see done. Yeah. So, and if you can even come up with interesting projects. They do have to be something like chemistry-ish, because I'd rather not try to do things like cell division. I mean, I do have a 1 credit hour from being an undergraduate in biology, but still, I'd prefer not. Yeah. It's dreadfully boring to me. Okay, lab safety. That's that stuff you did before. Remember the safety module, and you just did the safety contract. Congratulations, 5% of your grade. There you go. Okay. Woo! Got 5% down. The only way that's ever going to go down from there is if you just flagrantly violate the safety protocols in lab, okay? In which case I'll have to knock it down. But frankly speaking, you're going to have bigger troubles, because if you're flagrantly violating safety conduct, I'm just going to boot you out of lab, okay? Because I just can't have you doing things that are going to hurt people. This one didn't happen in my lab, but I actually, the lab across from me, boyfriend once squirted raw aspirin that hadn't been purified yet into his girlfriend's mouth, which is just nuts, right? So he squirted 5 different chemicals in his girlfriend's mouth. I would have kicked his butt right out. Usually the conversations I have to have with people are more along the lines of wear your goggles. So if I warn you to wear your goggles, you better start wearing your goggles. If I warn you 2 times, the 3rd time, you're just out. Okay? and I'll just kick you out and you won't get any grade for that lab. Okay. Um, Anyways, usually not a big issue. I've only had that happen like twice in my entire 15-year career of teaching labs. So, yeah, very, very uncommon. This is the grade scale right here. Everybody probably recognizes the grade scale by now. Okay, thank goodness. If you don't, then we have more problems than I thought. Okay. This is the normal stuff. I actually, this won't come up this semester, but I do allow use of AI. And I even have modules where I'll like have you constructively use AI for things. So I have AI being implemented in all my writing stuff. But it's a different way than most people do it. Next semester, we'll talk about. Okay. That's when that'll really come up. This semester, it's not really giving me a thing. By the way, if you try to use AI for organic chemistry, just know it is miserable at it. Like absolutely miserable. No idea what it's doing. Like I don't take off for using AI and you'll still end up with a score of like 12%. Okay? Just because the AI is so awful. It has no idea what it's doing. Like there's no nitrogens in this. Now there's a nitrogen. There's no nitrogens again. Now there's a chlorine. Just random stuff. It is really terrible. This is the schedule. It's the same schedule as that dynamic schedule. The dynamic schedule is where I actually make changes if things have to happen and get fixed. Okay. Okay. All right. Now, I just had recently talked to somebody that I did not realize people didn't know what this is, and they were like in their last years and didn't know this, and so I want to make sure people know this. I guess I never realized people like stop reading after I stop reading. Anyways, this is the academic calendar. It's required to be on every syllabus. Okay. And so like, did we have to be here for classes on Labor Day? No class, right? When can I withdraw from this class? Yeah. When could I drop with no penalties? Last week. Yeah, not as helpful anymore, right? But that's where all this stuff is, right? Funny enough, I've only given a few WPs in my entire career. WFs are so much more common because barely anybody ever drops when they're passing. So, yeah. Anyways, things to keep in mind, like there's November 3rd. That's when you can drop. Last day you can withdraw. Okay, this right here is final exam schedule. Guess what we do not have for this class, the lab. We do not have a final exam. Oh my goodness. You're disappointed in me, aren't you? Yes, you totally are. Okay. We are doing the ACS for the lecture during the previous week. But keep in mind that the last test is up here. So you've had some time. So it's really just the last exam is the ACS. We just require 2 hours, so we do it in here. Okay. Anybody have any questions about the syllabus? No? Okay. You may recognize modules. This is the modules for the lab, and we have safety modules and safety contract. Ooh, looking good. Okay. Hey, first meeting, set up. We did it. We got it. You get some points for that. Good stuff. Okay. This is a lab techniques, by the way. The ones in your book are better, but these are videos in case you don't understand what's going on in your book. They're lesser quality. Okay. But can be good supplemental. This is Tutoring Center. It's a QR code you can get Tutoring Center hours for. Okay. There's also tutoring up here at the end of the hall. Is everybody aware of that? Okay. Okay. And I would highly recommend you guys get into groups and talk to each other and help each other out. Okay. It will make life so much easier and better, right? You need to submit your own work all the time, everywhere. Okay. That the norm is not submitting one report for everybody. So you'll submit your own lab notebooks. You'll submit everything yourself in this course, okay? Okay. Unless otherwise stated, you'll actually do your own reactions. I'll tell you if you have to do them as a team, okay? However, you both work from the same drawer. You both are working on the same side, right? So you can like help each other out here and there, right? In fact, you have to. You kind of can. Like, tackle. Get out of my way. Do the thing. I don't know how that would work otherwise. You'll notice there's experiment and then there's LB for lab book. Okay. The experiment, it talks about what we're doing that week. Okay. The LB lab book is the lab book you're going to submit each week. Okay. So this right here tells you little notes about it. And I've given you information on what you need to do to prep for it. And I've given you extra information if you need it, okay? Now, what you're going to see here is that there's quite a bit of duplication of material here, okay? Because you actually have to show up to lab with the procedure prepared, okay? I'm going to go ahead and open up the example lab notebook because it's easier to talk about that. But I actually have like how to do this here, okay? In case you forget. All right, so this is an example from a previous student. It was a pretty nice lab notebook, but it's not like everything you could need for every single one, okay? But it has all the formatting perfectly. Now, this one was a composition notebook, as you can see, okay? And so we have here table of contents, and it tells us what page we can find each thing, okay? And then over here, we have the experiment title. Notice it's spelled out, has the number, letter, etc. Okay. Over here, we have a purpose. This purpose is not to learn something here. It is going to be we're separating two things using distillation. These are what we should get out. That sort of thing. Okay. Like what are we actually doing in the lab? Right. And this is a statement that you need to understand what you're supposed to be doing in lab. Okay. This is actually supposed to focus you in on what you need to do and how to be safe. Okay, reaction. If we have a reaction, you'll put a reaction there. How much of a reaction you need? You don't need a full mechanism, okay? What you need is the overall reaction, so you can do things like stoichiometry, okay? And you know overall what reactions we're doing. If you have more than one reaction, you may need to do more space. This is quantities and constants, so you have the name of the what you're using. There's going to be reactants, products, and solvents. Okay. So reactants are things that you put together to react. Solvents are the stuff you use to solvate. Those will all be listed in the lab as take this amount of that and add it. Take this amount of this and add it. Okay. Okay. And so you list all of those things here. Then you also list things you make. So any product you make, you should also list. Okay. All right. And then you're going to look up their physical properties that are important for this lab, okay? This is not every single lab is going to have the same thing because labs can be different on what we're doing with it, right? And so, for example, molecular weight, every lab will have that because you'll want it so you can do any calculations, right? And so that tends to be something you need for everything. Solubility. So solubility in H2O would be, is it soluble in H2O, right? Okay. If you have a solvent that is ethanol, what should solubility be? Solubility in ethanol. If your solvent is methanol, what should it be? Solubility is in methanol, right? If your solvent is water, then solubility in water, of course. Okay. And so what you're soluble in the solvent you're using, not in just a random solvent, water, because that's easy to find. Okay. All right. What if we're not doing anything? We're not dissolving anything in anything. Yeah, we don't care, right? Well, it's solvent, solubility, whatever. Okay. Density. Density is very useful if you're going to have multiple solvents working together or multiple liquids working together. Why would density be useful? Which is on top, right? So what's the thing on the bottom? The more dense thing, right? What's the thing on the top? That's dense thing. How do you know which thing's on the top and which is on the bottom? You look at the densities, right? Okay, so when you, this is going to happen. You're going to see it happen. Somebody's going to go, Dr. Clausen, which one's on top? What do you think I'm going to tell you? Yeah. Look at your procedure. Now, I will take the opportunity a few times in here. There's an experimental way to figure that out in case you don't actually know. Okay. And I'll actually teach you that as well. But I'm still going to be like, don't you have it in your table? Why don't you have it in your table? Okay. Melting point, boiling point. This is a distillation here. So, like, how do you figure out which thing comes off first? Boiling point, right? What if you're going to be doing melting points to find if you made the thing? You need its melting point, don't you? Okay. And this is where you record that. Okay. You could need other things. It kind of depends on the experiment. But these are like the most typical things you need, to be honest. So I'm going to be honest with you here. I really probably shouldn't say this because then you're going to get suckered into doing it. But if you listed this same sort of table where it has these things on the top of it, that would work for about 80% of labs. Because that's like the most common things you need. Yeah. But you do want to look and see, is there any other physical properties that make sense to put in this? Okay. Okay. This is where you put the references. Apparently, she used PubChem, which is a pretty popular place to get these things. It's actually easier to find them on Aldrich usually. So if you go to Aldrich, Sigma Aldrich, you can usually find them faster. Okay. You can also find them a few other places like NIST. There's a book in my office actually that you can find them even faster. Nobody uses it because apparently everybody hates physical textbooks now. But anyways, if you want to try it out, you can. But yeah, it is faster once you get used to it. But nobody ever wants to do it. Okay, so when you look these up, you're going to have to get their hazards. Okay? Anybody know where you find hazards? The SDS sheet, right? Yep, safety data sheet. That's that safety module's coming into play, isn't it? Yeah. Okay, so the chemicals here, you're going to look at their safety data, and you're going to record any safety data information, plus it's kind of what they look like, and key features that you might be able to tell what it is, okay? Because a lot of the features that you do, this is going to be real science. So let me ask, who here is cooked? Cooked is real science, right? Cooking is real science. Like it is. It's reactions, right? And so how do you know when a steak is done? The temperature, but not just the temperature, the color, right? So the color, the temperature, the firmness, these are all indicators if a steak is done and you've done the amount of caramelization on the outside that's necessary, right? And the same thing's going to be true for reactions. So when you're doing reactions, they're going to have physical properties that change, right? Because you're changing the chemical, okay? And so the truth is, like previous labs, we oversimplified it to the point where you really weren't doing the reactions. You maybe did 10% reaction, or you might have done way too much, okay? I'm now going to expect you to use physical properties to figure out if a reaction is done or not, okay? And you're going to have to react to that, right? So, like real reactions, just like baking or cooking, are not throw it in for an hour and don't look at it, right? If you did that with baking, would your cookies ever come out right? No. They'd always be burnt or undercooked, right? Same thing with reactions, because that is a reaction, okay? All right. So, some of the really important stuff here is like, for example, flammable. Is it flammable? Is it corrosive? This is where you're going to list that, okay? Okay. Now, this stuff right here is very important, and I will never, ever let you do a lab without this table here, this information here, and the procedure, which we're going to get to in just a second. Okay. The next part you're going to see, though, is a technique section. This is the section where you go to the back of the book and you put a technique if you need it. She always had her book with her, and so she just did like a summary of these techniques that made sense to her. Okay. But you can full out just like copy little diagrams and stuff. These are just to help you out. Okay. Because which is faster? Sitting there going, how do I am supposed to do this again? Or having a little diagram. Oh, I just done. Have a little diagram, right? You can save yourself a lot of time by just making 5 minutes, sketch out a little diagram. There you go. Okay. Okay. And so she had like little notes on how to do different techniques and what made sense to her. Okay. And that's what you do there. You can also put them in your procedure as well, if you'd prefer that. And so you're going to take that procedure, you're going to rewrite it in a way that makes sense to you. Okay. And in this procedure, when you're rewriting it, your book lists it as being like, you need to make a water bath, you need to heat it in the water bath, because if it says water bath a paragraph above and then you get to where you need to use it, it's not going to make any sense, right? And so your book doesn't do it efficiently when you're looking at actually performing it quickly, right? When do you need to make a water bath? You need to make it before, right? Like 20, 30 minutes before you need it. If you make it right when you need it, it's not going to get hot for another 20, 30 minutes, right? And you're going to be sitting there. Thanks, Dr. Clausen. And watching a water bath, right? Okay. So, like when you're doing this procedure, what I highly recommend is you're writing this procedure out, leave a little bit of room between these steps. And then when you see like, I need a water bath here, trace back up your steps, pull a little star, and say, hey, I needed a water bath. Make a water bath here. Okay? And that way down here, you have your water bath. Okay? All right. Now, notice how it's organized. This is incredibly important to get this organized correctly. This is not the place to be imaginative when we're trying to look at formatting of transmitting information, right? Have you guys ever seen web pages where they think they're being really imaginative? And it has all these video things that pop up, and then it has the thing that expands and then contracts, and the web page literally goes as you're trying to use it. Yeah. Not the place to be imaginative, right? Bad place. Not the right thing. You can be imaginative over on the bars. You can be imaginative other places, right? Same thing here. Okay. The place to be imaginative is not in the lab notebook formatting. Okay. It's in how to accomplish procedures, how to make new chemicals, new pathways, new ways of doing things. Okay. And so you want to split this up. Procedure gets like a 2/3, 60%. Your notes, observations, modifications gets the other. Okay. And she left a little blank space so that she had a little extra room in case she needed to make notes. Right. And what you do is you have your procedure, and any place that you have things that has observations, measurements, I tell you changes we're going to do. Sometimes I'm going to just change procedures a bit because it works better with our equipment and it works better for you. Okay. And there's some places that your book's just not as good at, like they explain the procedure, but it doesn't actually make sense to you. And then I'll give you a better way to do that. It'll work better for you. Okay. And you'll write in that new procedure here, and that'll be your note, right? Like let's say we have a procedure here that says weigh it on the balance. What would you write over here? Yeah, the weight, right? Yeah, record the weight. There you go. Measure out this amount of substance. You measure that amount out. You say that I measured this amount out. Little observations of that substance. Hey, it was a slight yellow color. I was expecting it to be clear. Okay. That would tell me, well, somebody probably contaminated the bottle, didn't they? I was trying to measure this out and I spilled about 10% of my solvent. Okay. That's the sort of things you're going to need to put there, right? Okay. See all the little changes she had to make to procedure. She heated it up too much. She had to back off the temperature here. Okay. Okay. How do you correct things if you get them wrong? Yep. Single line, right? And then put the correction. Okay. Did I tell you guys about the doctors? 2 different doctors? Yeah? No? Okay. Okay. So good lab notes can make all the difference in life. Okay. And all of you are going into fields that you need to keep good lab notes, right? They may not be lab. It could be medical, but you all need to keep good notes, right? So no falsifying. Be very careful about that. Okay, so we have our procedure. That is the part right there. Once you have that stuff done, you're ready for lab next week, okay? And so next week, what are we coming with? Lab notebook, procedure, lab goggles, safety, physical properties. Okay? So your lab notebook with physical properties, safety information, and the procedure all written out in the proper formatting, right? And your lab goggles. What do you have for writing? Pen. Okay? So you need a pen to write. Can I use yellow ink? No. Could I use red ink? Yeah, sure. Fine. Blue, black, whatever. But it needs to be something darkish so I can read it. Okay? All right. Anybody have any questions about that so far? Okay. If I don't come with this, what happens? Yep. Not going to let you start. Okay? Conclusions are what you do at the end afterwards. So I finished my lab. I'm done with everything. I got all my measurements done. This lab, oftentimes you'll have like one thing that is not done at the end of that lab, okay? And that's like melting points in the final weight because we'll let it dry. And so the next lab, you'll come here, you'll take care of that, and then you'll have that final piece of data. You'll write out your conclusion, final piece of data here, put your sample in your book here using some tape, assuming it's not liquid or gas. And this final conclusion, this is typically things like, I believe I obtained my product. It had a melting point of this. I obtained this amount of weight, and it had this % yield. Okay? And that's the sort of things you typically have for a conclusion, okay? They are not, I made this product, period, and I have no evidence for that, because that's not a conclusion, is it? At least not scientifically. And it also is not, I learned a lot in this lab. Okay? I'm sorry. I'm glad that you learned a lot. Awesome. But it's not a conclusion. Okay? Okay. Does anybody have any questions about that? Okay. So remember how we did the CAM scan? That's how you submit these. If you have any data like a spectra, a graph, etc., that you need to put in this is how you do that. You print it off, you lay it across the page like that, and you staple it one side. Okay? So it opens across the book. When we have it come up, I'll show you in with your book. Okay? Yeah. But know that don't just like staple it, and you do need to staple it, but you just don't staple it in randomly. Okay? Okay. That's the important part, that you don't just like, wing it. Okay. Submitting, CAM scanner, you scan it in. You can just directly submit it using the CAM scanner straight into Canvas, okay? And really easy, real simple. They're all multiple pages all the time. Did you see how it's 1 page per? Okay. Don't take 2 pages per. I can't read it. If I can't read it, you didn't submit it, okay? I mean, hopefully everybody realizes that, like, if you submit something that your professor can't read, you're not getting 100% argument. Okay? You're definitely getting closer to a 0 than 100, right? Okay. All right. Any questions at all? Anything whatsoever? Okay. I will unleash you upon the world. You all have a wonderful day. If you have any questions, comes up, talk to me. Have a wonderful day. Have a wonderful weekend. I highly recommend you guys get together like every Wednesday or Thursday and like prep your lab books. Like get some friends to remind you and just every Wednesday or Thursday. Okay? Really helpful. Okay? Uh-huh.
So for this one, do I need to check all these?
You don't. No.
Okay, and what I need to upload here?
So normally what you do is add file, and then you go upload, browse, and then take photo.
Okay, photo for what? For
And then what you do for now, just take a photo like whatever. Okay. But usually what you'd have is you'd have your desk, your drawer, you'd have all that cleaned up and ready to go.
Mm-hmm.
And then you take a photo with
I took a photo of just one door. I can upload that now.
Yeah. Just for now, take a picture of whatever, because I'm just making you practice. Okay. Yeah.
We need to send this one.
Yeah, that's the checkout. Did you already do checkout?
I'll do it.
Sounds good. Yeah, you got.
Because it looks the same.
Yep. It is mostly the same except for those little boxes have different directions. Hey, Aurora. Take care. You both have a wonderful night, wonderful weekend. Woo, ghosts. Careful. Good shirt choice. That's the Cumberland Science one, right?
What?
You got the Cumberland Science one?
Oh, this one?
Mm-hmm.
This shirt, I got it last semester, last year. Yeah.
Fantastic. That is the perfect shirt to wear again.
Yeah. And it's actually comfortable and soft. So I like it.
It is. It's an actually nice shirt. Yeah.
Mm-hmm.
It has nice like logos.
Yeah, even from the back.
Yeah, it looks
really
nice.
good.
Yeah,
Yeah.
yeah. I was pleasantly surprised.
And it was like for free, so
Yeah, you can't beat that.